Welcome to this video covering sections 9.3 to 9.4. In the last video we covered the optimization of the area and perimeter of rectangles. When optimizing area, we are trying to determine the maximum area for a given perimeter, and when optimizing perimeter, we are attempting to determine the minimum perimeter for a given area. In this video we will look at the optimal measures for rectangular prisms when attempting to minimize the surface for a given volume and maximize the volume for a given surface. I will be introducing a couple more geometric facts that you must become familiar with during this unit. Based on the handout that you received and should have completed entitled 9.3 and 9.4 Square-Based Prism Optimal Measures, you should have discovered that for a given volume, the rectangular prism with the minimum surface area is a cube. In the handout, you had to complete the chart that you can see here. Some of you had some difficulty with this, so I'll quickly go over how to complete the chart. So the first part of the chart we're going to go over is how do we go from the length of the base to the area of the square base. So if the length of the base is 1 centimeter, then I can know the area of the base is 1 centimeter squared, because it's essentially I have a square. I'm just going to make a really small one over here so we can cover this. This is 1. Therefore, we know that the area of the square is 1 squared, because the formula for a square is s squared. 1 squared equals 1 centimeter squared. Similarly, if the length of the base is 2, then I know the area of the base is going to be 4 centimeters squared, because 2 squared equals 4 centimeters squared. And 3, length of the base 3 is going to give us an area of 9 centimeters squared, etc., etc. You can go throughout here and you will see that the length of the base is squared, and that gives us the area of the square base. Now, by now at this point in the course, you should know that when calculating volume, you're simply multiplying the area of the base by the height. Therefore, to calculate the height when you know the area of the base and the volume, you need to divide the volume by the area of the base. So I would be taking the volume that I have here, dividing it by the area of the base in order to find the height here. So for prism 1, that gives us 64 divided by 1 gives us a height of 64. For prism 2, 64 divided by 4 gives us a height of 16. For prism 3, 64 divided by 9 gives us a height of 7.111, etc., etc. In all cases, we took the volume, we divided it by the area of the base to find the height. To calculate the surface area, you substitute the values you have put in the area of the base in the height columns, here and here, into the surface area formula. In this case, it is easiest to use the surface area formula 2 times the area of the base plus 4 times the area of the sides. The fact that for a given volume, the rectangular prism that has the minimum surface area is a cube can be seen in the chart where the area of the square base is 16 centimeters squared and the height is 4 centimeters, making the surface area 96 centimeters squared. And that can be seen right here on our chart. This means that the dimensions of the cube are 4 centimeters by 4 centimeters by 4 centimeters. So if I had a cube, it's 4 centimeters by 4 centimeters by 4 centimeters. As I noted in the previous video, making a chart like this is not very efficient. Since you know that a cube has the minimum surface area for a given volume, you simply need to find one of the side lengths of the cube. And to do that, you must, first, write the formula for the volume of a cube, V equals S cubed. Next, you substitute the given volume into the formula. This gives us the equation 64 equals S cubed. Next, we would have to cube root both sides of the equation to find the length of the side. When we cube root 64, we get the answer 4, and that tells us that the side length is 4. If we then wanted to find the surface area for our cube, We would then substitute the cube root of the given volume into the surface area. So our surface area formula is surface area equals 6s squared, and we would substitute in 4 for s, and we would get 6 times 4 squared, and eventually we would get that the surface area is 96 centimeters squared. That surface area is the minimum surface area for a rectangular prism that has a volume of 64. Some of you may be unfamiliar with cube rooting. To understand cube rooting, it is helpful to remember something that I reviewed with you earlier in the year. When I square a number, such as 2, I'm saying that if I had a square with a side 2, the area of the square would be 4. And you can see that here, 2 squared equals 4, which is the same as saying if I had a square with a side length of 2 centimeters, my area would be 4 centimeters squared. When I square root a number, let's say 9, I'm saying that if I had a square with an area of 9, I would have a side of 3. So the square root of 9 equals 3. The area of this square is 9 centimeters squared, therefore the side is 3. Similarly, when I cube a number, let's say 4, I'm saying if I created a cube with a side length of 4, I would have a cube that has a volume of 64. So 4 cubed equals 64. One side length of this cube is 4 centimeters, which means they are all 4 centimeters. And that means that this cube has a volume of 64 centimeters cubed. Vice versa, if I cube root a number, I'm saying if I had a cube with the volume of 64, the side length would be 4. So here I've cube rooted 64, that equals 4. What that's saying is this cube has a volume of 64 centimeters cubed and therefore has a side length of 4 centimeters. I will briefly go over how to cube root using the TI-84 that you have access to during class. If you are using a different calculator, you will need to figure out how to cube root with your calculator. Of course, if you have difficulty figuring this out, please come see me for help. To cube root with the TI-84, you need to press the math button. The math button is this button right here, and I'll put a little circle around it. This is the math button. When you press the math button, you will then see a screen that looks like this. You then want to press the number 4 on your calculator, which will select cube rooting. You then enter the number you would like to cube root. This example question from the handout asks that you determine the dimensions of the rectangular prism that has the minimum surface area, because having a minimum surface area will prevent the loss of heat for the transported food. To solve this example question, you can use the method that I just described, but you do not need to find the total surface area, just the dimensions of the prism. The first step is to write the formula for the volume of a square. The second step is to substitute the given volume. The third step is to cube root both sides of the equation to find the length of the side. After cube rooting both sides of the equation, I can see that the side length is 52.5 centimeters. The dimensions, therefore, are going to be 52.5 times 52.5 times 52.5. That is, the cube will have a length of 52.5, a width of 52.5, and a height of 52.5. Another geometric fact that should have become apparent to you when completing the handouts for 9.3 and 9.4 is that for a given surface area, the rectangular prism with the greatest volume is a cube. In the handout, you are shown 3 prisms and are told that they all have a surface area of 24 centimeters squared. You must determine which of the prisms has the greatest volume. Your chart notes the height and the length of the base of each of the prisms, and it is up to you to determine the area of the square base and the volume. Just as we did for the previous chart, you can find the area of the square base by squaring the length of the base. So if the length of the base is 1 for prism 1, the length of the base is 1, the area of the square base is also 1, because 1 squared equals 1. For prism 2, the length of the base is 2, and the square base is therefore 4 centimeters squared, because 2 squared equals 4. For prism 3, the length of the base is 3, therefore the area of the square base is 9. To find the volume, then, you simply have to multiply the area of the square base by the height, and that will give you the volume. And so we do 1 times 1.5, we get 5.5 centimeters cubed. We do 4 times 2, we get 8 centimeters cubed. And we do 9 times 0.5, and we get 4.5 centimeters cubed. The fact that for a given surface area, the rectangular prism with the greatest volume is a cube can be seen in the chart from the handout, where the length of the base is 2, the area of the square base is 4, the height is 2, and the prism, which is a cube, has a volume of 8. So on our chart, that's right here. That is prism 2, this one here. Again, as I've said now numerous times, making a chart is not very efficient. Instead, you can first write the formula for the surface area of a cube. After I've written my formula, S surface area equals 6s squared, I can then substitute the given surface area into the formula. I will then have the equation 24 equals 6s squared. The next step is because I want to isolate s, I'm going to have to divide both sides by 6. And I'm dividing by 6 because right now 6 is being multiplied by s squared, which you can see here. 6 s squared means 6 times s squared. So to isolate s, I'm going to divide both sides by 6. When I have divided both sides by 6, I end up with 4 equals s squared. And again, now I'm still trying to isolate s. S is being squared, so to isolate s, I need to square root it. And if I square root s squared, I'm going to have to also square root 4. So my next step is to square root both sides of the equation. When I square root both sides, I end up getting that s equals to 2 centimeters. That tells me the side length of my cube. Now to find the volume of the cube, I'm going to have to substitute the value of the side into the volume formula. That would then give me v equals s cubed. I substitute 2 in, because that's the side length, and I get 2 cubed, which gives me a volume of 8 centimeters cubed. A quick recap. For a given volume, the rectangular prism with the minimum surface area is a cube. And to find the minimum surface area from a given volume, you must write the formula for the volume of a cube, v equals s cubed, substitute the given volume, cube root both sides of the equation to find the length of the side, and then 4, substitute the cube root of the given volume into the surface area formula for a cube, surface area equals 6s squared, to find the cube's surface area. The second point of the video, for a given surface area, the rectangular prism with the greatest volume is a cube. And to find the maximum volume from a given surface area, you must first write the formula for the surface area of a cube, surface area equals 6s squared. 2, substitute the given surface area. 3, divide both sides by 6. 4, square root both sides. And 5, substitute the value of the side into the volume formula for a cube, v equals s cubed, to find the cube's volume.